Okay guys, and let's try out this differentiation with, okay guys, let's try out this numerical. Differentiate s and x raised to x with respect to x. Appears very simple. It is simple, provided you are aware about the tricks that you are supposed to use for this numerical. So first thing, it is sine x raised to x. So d by dx of sine x, we know, straightforward, it is cos x, first step done. Then we have got to differentiate, chain rule we have got to apply. So then we have got to differentiate x raised to x. Fine. D by dx of x raised to x. Now if it would have been x raised to n d by dx, then we would have used our normal formula, right? We would have used this is equal to n x raised to n minus 1 and done. Alright, so but here it is x raised to x, a variable. So whenever you get these type of numericals, then we have got to go via log method. Now log method in the sense, x raised to x we substitute as whatever you feel like. Let's substitute it as t. Alright, so we have got to take log on both the sides. So log t would be equal to x log x. You know, if it is log x raised to x, you know this x comes over here. So that's what I did over here. So x log x. And then differentiating both the sides. D by dx of log t and d by dx of x into log x. Obviously, this is uv. So here again we have got to apply uv and get up to our solution. Alright, so keeping this in mind, let's progress. It is y is equal to sine x raised to x. So we have got to do d by dx of y is equal to d by dx of sine x raised to x and chain rule d by dx of x raised to x. The trick that I explained right now. Alright, okay, so for this there's no problem at all. This comes to cos x raised to x, and this we have got to do it separately. Alright, so let's do some assumption as I did it over there. So let me assume x raised to x is equal to t. Alright, so t is equal to x raised to x. Now I've got to put in log. So x variable, x raised to variable. So I have no other choice but to go ahead via log method. So I've got to put log on both the sides. That's what I did. So maybe I'll come back directly. I'll come to this part directly. So log t, same thing, is equal to x log x. Alright. Now I've got to differentiate this by d by dx, and this also I've got to differentiate d by dx of x log x. Now it's uv. So what happens is, if I do this, this is, we know d by dx of log x is 1 by x. So here it would be 1 by t and dt by dx. Alright, and here what's going to happen, it is u into v plus v into u. So it would be x d by dx, I take it this as u and this as v. So it is u into dv by dx, and our v is log x. So log x plus, so here it would be log x v du by dx, that is dx by dx. Alright, so v u u v. Fine. So what would happen is, this is x over log x is 1 by x. Alright, plus, so this is log x into 1. Alright, so this would be 1 plus log x, and here I have 1 over t dt by dx. So dt by dx would be equal to t, I am taking it there, t into 1 plus log x. Alright, so dt by dx. Now if you check out over here, this was what? This was x raised to x. So if I write a step over here, so dy by dx, dy by dx is equal to cos x raised to x, and this was dt by dx. Okay, so this part which was there, that is dt by dx. So what I do is I write here cos x raised to x into this thing. T also I can substitute. Okay, well, let me write it here, t into 1 plus log x. Alright, and this becomes cos x raised to x into t. What is t? Let's go back here, x raised to x. So x raised to x into 1 plus log x. Alright, so this is our answer. Okay. So what, in nutshell, what did we do? First it was sine x raised to x. We know we had to apply chain rule. So sine is no problem. We know it is cos, so no problem. But x raised to x, that is variable raised to variable. Whenever we are differentiating variable raised to variable, we have got to involve log into it. And whenever we have got to involve log into it, then we have got to do by substitution method. So substituted x raised to x to t. Alright, then we put log both the sides. So it became x log x raised to x. So x comes over here. So this becomes uv, and this is log t. And then we went on differentiating. Alright, so we came back here. Log t, we know log x d by dx of log x is 1 by x. So this also would be 1 by t, and dt by dx. Alright, so this is implicit. This is different, this is different, implicit, different. Okay, alright, so x d by dx log x, we get this by uv. This is x is our u, this is our v. So x u into d by dx of v, that's what we do, and plus v into d by dx of u. So that's what we do. So we get it. So that was simple story. So ultimately what happens is we get 1. This is log x into 1. So 1 plus log x is our 1 over t dt by dx. So dt by dx, because this was what? This was dt by dx. We substituted this here, right? So when we substituted here, we substituted this as x raised to x, we substituted as t. So that was, this part was dt by dx. Alright, this part was dt. So that's what we want. So dt by dx is t into 1 plus log x. So dt we jot it down over here. Alright, so this is what dt by dx. So we jot it down over where? We jot it down over here. This one. We jot it down over here. Cos x raised to x already was there, and this was dt by dx. Alright, so dt by dx, we got the value. We substituted over here. So our answer was cos x raised to x, x t. Alright, t is what? T is what? T is over, come back over here. T is over here. Alright, that is what is t. So we substitute that t over here, x raised to x, and 1 plus log x is over here. Alright, so that's how we do it. Alright, so please recap always. Alright, so we learned here something about this, something about when variable is raised to variable, how to tackle it. Alright, that was the main theme of this numerical. Okay.